Hi everyone, my name is Martin. I'm a professor for interactive experiences at the University of Applied Sciences, Upper Austria in Hagenberg. And today I will give a talk about our paper titled The Effects of Avatar and Environment on Thermal Perception and Skin Temperature in Virtual Reality. This paper is co-authored with Lukas, Jackermeier, Valentin, Schwind, and Niels Henze from University of Regensburg in Germany. Okay, so let's dive right into it. How humans perceive their ambient temperature can be affected by the design and the visual appearance of the surrounding environment. And this phenomenon can be explained by the Hue-Heat Hypothesis that postulates that warm colors, yellowish, reddish colors, are perceived as warmer than cool colors, bluish, greenish colors. And previous work found, for example, that participants in an aircraft cabin, as we can see here in this image, had warmer sensations when yellow light was used compared to blue light. Right? So they felt warmer, more comfortable during yellow light, during warmer light, compared to colder bluish light. And this effect could also be shown by the mere exposure to visual information. In this study, the authors used images depicting different thermal conditions, and these thermal conditions were presented on a common LCD display. So we had a cold image, hot images, and control images. And results show that not only the thermal comfort was affected by but also the participant's skin temperature. So participants had a lower skin temperature when hot images were presented compared to cold and controlled images. Furthermore, such findings could also be replicated in VR. In this study, participants had to grasp real steel cups that were either cold or warm, and in VR these cups were presented either red or blue. And the findings suggest that the color of a cup in VR systematically affected participants' temperature sensation. The red cup was perceived as warmer than the blue cup, and the reaction times to discriminate between hot and cold cups. And overall, these results suggest that humans' thermal regulation and also subjective perception of temperature is highly plastic and depends on the visual appearance of the surrounding environment or the objects. Now let's think about VR. One fascinating characteristic of VR is that we can transport users to all imaginable places. As we can see here in this image from Everest VR, users can climb the Mount Everest and visually experience extreme thermal conditions. But it's not only about the environment, but also about the virtual body. In VR, designers typically use avatars to represent their user in virtual environments and create the feeling of having a body in VR, right? This is similar to the real world where we have a body interact via our body with the real environment. In VR, we have an avatar, a virtual body, and interact with the avatar with the virtual environment. And as we can see here in Skyrim VR, the virtual avatar has superpowers and can cast fire spells, and therefore also represents extreme thermal conditions. And therefore, from a design perspective, when creating virtual worlds and characters depicting extreme temperatures, it is important to understand the effects on the user, yet unknown. And therefore, we're wondering, okay, how do the virtual environment and avatar affect users' thermal comfort and skin temperature in VR? And to answer this question, we conducted a user study with 32 participants using a within-subject design with two independent variables, the Henze and the environment. And both independent variables had two levels, so we systematically manipulated the Henze, either fire Henze, as we can see here, or ice Henze. And we also systematically manipulate the environment, either a fire environment or an ice environment. And participants had to perform actually one simple task. They had to shoot targets by performing a specific gesture, as we can see here in this image, and here the targets. And we attached the leap motion onto the front of the HMD to allow hand tracking. So when participants moved their hands, the motion was transferred onto the virtual skeleton of the virtual hands. And we also attached thermocouples onto the back of the participant's hand to assess the skin temperature. In addition, we assessed the thermal comfort and the thermal sensation using established scales. And we also assessed the sense of presence using the IPQ, the Eye Group Presence Questionnaire. Okay, now let's have a look at the results. We found a significant interaction effect of hands and time. So participants' skin temperature decreased while embodying fire hands compared to ice hands, right? The skin temperature increased while embodying ice hands. Now let's have a look at the subjective perception of temperature. So we found a significant main effect of hands and a main effect of environment on the participants' thermal sensation. So participants had felt warmer in the fire world compared to the ice world, with fire hands compared to the ice hands. And we also found a significant main effect of environment. So participants felt more comfortable in the ice world compared to the fire world. Okay, now let's wrap up the findings. So we found that fire hands decreased and ice hands increased skin temperature across time. We also found that participants felt warmer in the fire environment compared to the ice environment. And we also found that participants had a lower thermal comfort in the fire environment compared to the ice environment. This means that avatars and their virtual environment can affect thermal perception, as well as thermoregulative mechanisms as indicated by the differences in skin temperature. And this psychophysiological impact of avatars have to be considered when designing VR scenarios representing different thermal conditions, such as virtual avatars with fire abilities or ice abilities, or virtual environment that represent or depict extreme thermal conditions such as ice worlds or fire worlds, right? And with this, I conclude this talk and welcome your questions. Thank you so much.